Hi there. Today's video basically it's based on me sort of showing you our little product that we make, magnetic polarity tester. Okay, what it is, it actually any magnet, okay, has got a north and it's got the south. Although I do make a sort of electronic units, but they are quite expensive, I must say. So I had requests from customers for specific applications, for everyday use, and it's a pocket size, no batteries, no wires, it's a mechanical thing. So I come up with a plan and I started actually supplying and making them. Okay, every magnet has got a north and it's got a south side, a pole, let's put it that way. Whether it's a round, okay, like this one here that you actually see, or it's a square or rectangular or whatever the case may be, it has got two poles, north and south. How do you determine? If I give you if I give you a magnet like this, where is the south here, north here, or where is it? You wouldn't know. There is no way. And of course, in electronics, there is quite a few sort of areas where you have to know which is your north, specifically more, not only that you can measure, sort of back, not only that you can measure on the magnets, you can also measure on the coils that, you apply the voltage to, and inductors and things like that. Where is the south, where is the north? And you can see over here, I have calibrated mine. This is my demagnetizer unit and a magnetizer that I use here at the shop on one of the benches. Okay, of course we also make magnetizers and demagnetizers. So if you need one, you know where to come to. What happened is, this is south. So I know that when I switch it on, if I reverse the polarity over here, then this becomes north. And bottom of the coil is, right now, bottom of the coil is north, and this is my south. So basically, that's what this little unit is all about. Now this unit, if you look at it very carefully, okay, you will see over here, okay, I don't know if you can really see it, but nonetheless, it says the magnetic polarity tester. Okay, when you see the black color, that means you actually the magnet that you're actually measuring, that is a north pole. And if you see the white color of the device inside of this little instrument, that means that is the south of the actual magnet that you're actually measuring. Now, let's assume, okay, right now, I put it in any mode, it doesn't matter, okay. Now I want to measure, say to see what is, okay, let me just get another magnet. Come on now. Let me get another magnet. Okay, I'll use this one here, okay. Now, how do I know where is south, where is north? I wouldn't know. But just by putting this, okay, I can actually see it's showing me a black color. So the black color means that's north. So which means that this side is my north. And to prove, as I said, I have calibrated this one out with my digital electronic magnetic polarity tester that we also make, but they're expensive, as I said, compared to this one here now, and yet just as accurate and very easy to actually use. Now let's assume I got it in any mode, doesn't matter what mode. Watch it now, okay? Now I see over here, it's black, so which means that's my north. Watch when I tilt the magnet. Okay? You can see over here, it's white, okay? And that is south, because the white is the actual south. If I see the white color on top, that means that is the south. Now watch even from a distance. As I tilt, it actually flips over. Look at it. South. Watch north. It's black. So it's a very, very, very easy unit to use and to carry with you in your pocket. As I said, in biomedical, also very important, and also in mechanical sort of, especially engineering techniques and things like that, where it's very essential whether you're using a north or south, if you're, especially for grinding machines, if all your electromagnets are sort of polarized in same direction, or maybe one is miswired and things like that. And also for testing the actual guitar pickups to see if all 6 strings under the string, the magnet, the permanent magnet that they actually use on the pickup is all of them are the same sort of polarity, north or south, let's put it that way. And if one is out, your guitar is going to sound very sick, let's put it that way. And a lot of people, and sometimes, these things, they get demagnetized because of the electric fields around, etc., and so on. So it's a very, very broad spectrum, except not many people are familiar the uses of and the need for north and south to know. But nonetheless, we make them, we got them, so if you do need one, not a problem. Now, look at it over here on the electromagnet. Not only on the, as I said, not only on the magnets, you can also use it on the coils. Now, the unit is off. Okay, now I'm going to put it, and it's showing me, say it's wherever, say it's on black. Now I see black color. But this is south. And it says over here, for south, it must show me the white color. So watch what's going to happen now. How it's going to flip from, okay. Can you see it? There we go. I don't know if you can actually see it. Let me just do this. Okay, can you see? It's a white color. Okay, I don't know if you can really see it on the camera. Okay. Okay, it goes in the rhythm with the magnetic field. Okay, that's the magnetizer. Now let me just, okay, watch it now. It's south, okay? And if I go at the bottom, that's my north. Watch how the magnet actually changes. Okay, let me try to zoom. Let me try to zoom and move the, okay, watch it now. Okay, watch it. It's white color. White color. Watch it now as I go. It changes because my north is at the bottom. I go towards the top, it changes towards the white. And it is white in color. So with ease, just by touching on the actual unit or wherever I am, like even if I do it over here with the magnet, let me just try to zoom so you can see it clearly. Okay, that's south, That's south. Now watch when I change it now to north. North is black. So now, this screwdriver over here, let me now just make it smaller. Okay, now this screwdriver, both of them are demagnetized. What I'm going to do is I'm going to magnetize it. And on this screwdriver, I will, once it's magnetized, obviously you can't have exactly the same. On one side will be south, on the other side will be north. And then you will see, and we'll be able to see where right in the middle that they actually equal in strength and they cancel each other. So it doesn't flip. And you'll see once you exceed certain sort of position, it will flip from north to south. Okay, now let me first magnetize. As I said, not sticking. Watch now when I magnetize it. Okay, I'm just magnetizing. Okay, I'm just magnetizing the screwdriver. Okay. Okay. There we go. Okay, now watch now. Now screwdriver is magnetized. Watch it there. Okay. Now on this screwdriver, I'll be able to see which side are magnetized. Okay, let me just bring it closer. Now when I put it over there, okay, now watch it now. Watch it now. Can you see it flipped over? Okay. It flipped over. Watch now, at certain point. Can you see it flipped over to north? So that's my north. That's my north. And now, watch it. There we go. South. Can you see it's going to white? I don't know if you can see it clearly. Okay, let me go backwards. Can you see it's flipping over towards the north? I see the black color. So I can precisely see that I magnetize the screwdriver with the south, north over here and south over there. And as I said, so in a nutshell, that's a quick sort of demo. And of course, we make them, and they're available, of course, at the store over the counter. So, and it's very, very, very reasonably priced. And it's not only for electronic or mechanical or for doctors or for medical field or whatever. Anybody, even for the teachers at school to demonstrate, polarity of the magnets and things like that. And sometimes even for fun. Yeah, on that note, I say thank you for watching Batos magnetic polarity tester that we make and sell. Thank you.